Welcome. We're going to do task 4.7. This is the last task for module 4. It's called More Features, More Functions. We're looking at characteristics and features of different functions. You can see the equation, domain, range, intercepts, maximum, minimum, intervals of increase, decrease, sketch the inverse. I think I'm going to hold off on the equation, and instead I'm going to look at some of these characteristics here. So first thing, let's look at this first one here. The domain and range of the function. You can see that the domain, it begins at -2 and it goes on indefinitely. Same thing with the range. There is two intercepts. There's an x-intercept at 2, 0, and there's a y-intercept at 0, and it looks like approximately maybe 2/3, something like that. The minimum value here is at -2, -2. It is increasing over the entire domain, so from -2 to infinity. The next one, the domain continues infinitely to the negative and also to the positive. The range, it doesn't include 0. It gets close to 0 but doesn't quite get there. But it goes infinitely in the positive. We can see there is a y-intercept here at 0, 4. It's going to approach the x-axis, but it's not going to cross. And the minimum is going to approach. It's going to approach the x-axis. It's decreasing over the entire domain. Next one. Looks like an absolute value function. Domain is unrestricted. The range is as low as -4. The intercepts, we can see x-intercepts at 2, 0, as well as -6, 0. Those are the x-intercepts. The y-intercept is at 0, -2. The minimum value is at -2, -4. It is increasing. It's increasing from -2 into the towards infinity, and it's decreasing from -infinity to -2. Last one, domain. It's unrestricted. Range is unrestricted. Intercepts, well, actually that's not true. The range does bottom out. Yeah, the range here, if we look at it, we can see the range is going to go to 5. But the domain is unrestricted. Intercepts, we can see one. It's at 0, 2. And there looks like an x-intercept at something like -1.5. Approximate that. Maximum value is at 2, 5. It's increasing from -infinity until it gets to 2. And it's decreasing from 2 until it gets to 4. You can also see the red dots are going to express the inverse. So if I go ahead and connect these dots, you can see the shapes of these, keeping in mind that y equals x, every point is a reflection over y equals x. So this one's going to look something like that. And then this one here is going to look something like that. And then this one here is going to look something like that. The next part was coming up with examples, so yours will be different. If it's always increasing to the x, right, it's exponential, or you could have a linear 3x plus 5, symmetrical, x squared minus 3, or the absolute value of x, a minimum of -2 at x equals 5. Well, if x is equal to 5 here, the square part becomes 0, and so the value will be -2. If it's anything but that, that square will be a positive and we'll push it higher. Same thing with absolute value. A function decreasing, so from it's looking at vertex here at the -3 value, or it's also looking at absolute value with a -3 value. 0 real roots, this is above the x-axis, this is below it. It has a domain here. If x is less than 3, it'll be the square root of a negative value, so it won't be real. And you could also set a constraint on the domain and give a function like x minus 3. Constant rate of change, how about linear? Second difference, how about quadratics? Function whose inverse is also a function. So you can picture here with 4x plus 5, something like that is going to have a inverse function, and 2 to the x, something like that is going to also have an inverse function.